So today we are going to talk about exceptions. So welcome to leveraging typed exceptions for cleaner error handling. We're going to look a little bit at how we might handle error conditions in our code without exceptions, and we're going to see some drawbacks of these approaches and how exceptions can help us. All right, so let's get into it. So again, hello from Austin, Texas. And this is where I am, and this is where you are. It would only be a 19-hour flight from here to where you are right now. So I am on Twitter. Feel free to follow me and say hi. And also, if you want the slides for this presentation, they are all available right here. It will download a PDF. Okay. All right, so let's get into it. Let's look at validations. So I'm going to show you a pretty typical example of validations that you might see in code today, which I call pretty painful. And this is kind of what it might look like. You might have an if statement with sequential calls to validation methods, with ampersands. So if any one of those methods returns false, which means the validation failed, then the transaction here is not going to happen, and then we might return false. So there are two things here that you can look at. One, your code is already pretty nested just to do some basic validation of things. So you've already got some nesting inside of an if statement. Yeah, so this is kind of a lot of extra code. And the other thing is, you are going to return true or return false, because whatever calls this code needs to know whether or not do some transaction was successful, right? So one typical way to do it is to return true or return false. So, and now each validation method might look like this, right? So it'll return false or return true. It'll return false if an error condition happen is going to return. Now, a simpler way that code would be return some error condition. So it will only be one line. But if you do that, the code becomes a little bit less readable. But these are a couple ways. These are a couple ways to do it. So same thing for validate thing 2, validate thing 3. And it works. The thing is, upstream methods now must adapt their behavior based on whether or not your code returned true or false. And also your code is going to have a good amount of nesting. So, and when it comes to nesting, it's always fun to look at this code example, called the Hadoken pattern, right? You get all these nested if statements. It can get out of hand pretty quickly if you want to test for all those things. So I'm going to show you a different approach which scales better, and that's by leveraging exceptions. So now if we start using exceptions, your code can now look like this. Instead of being nested inside of an if statement, you're going to call those individual validation methods before you call your code that says do some transaction. And so what's going to happen is, if any one of those validation methods throws an exception, then do some transaction is not going to get called. Even better, if any of these methods, validate methods, throws an exception, it's going to bubble upward. So any code that is calling this is going to see the exception. So this code itself no longer needs to signal upstream of it with return true or false. So now your code is a lot flatter, right? You no longer have the if statement, and the error handling is a lot more graceful. So, and the nice thing is the individual validation methods also look better. Now your validation method can just say, if some error condition happens, then throw a new exception. You no longer have that if-else statement, or you no longer have to do a return and then not some error condition, which is a bit counterintuitive. Now this code reads a lot more like human language. If some error condition happens, then throw an exception. I can do this code and be like, oh, okay, it's obvious what's happening. So same thing for the valid thing 2 and 3. So yeah, those validation methods don't need to return anything. They only need to throw an exception on failure. And the upstream methods don't have to care. All right, so now we're going to look at a much more complex use case. So let's say you are building a web service. Let's say you're building a RESTful endpoint to retrieve products for a user. Get products for user. That's what your code might look like. So it has two possible failure modes. One is a user has no products. That's okay, right? It's really a fault. It's just, hey, this user has no products. But another possible failure mode is that the user could not be found. It is possible for somebody to pass the wrong user ID to your endpoint, and the user could not be found, right? That's really not normal. So let's look at a possible architectural stack in your code. You could have your controller, right? ProductsController get products, to which you pass the user ID. Below it, you could have a service, product service get products for user, to which again you pass the user ID. So then this service could be calling two repositories. One is a user repository with a get user by ID method, right? So the first thing that we want to do is retrieve the user that was passed. And then once we have a handle to this user, we could pass this user to the next repository, to a call to the next repository, which would be the product repository, get product for the past user, right? So I am passing this user object to the next method. All right. So what we want to look at right here, we're going to explore what happens in get user by ID. Okay, so here's you go, get user by ID, which would return a user. So here's a possible method for get user by ID. This uses the doctrine ORM using the doctrine query language. This is what you're seeing right here. And we call get single result. So the question is now, what happens when this user ID is bogus, right? Somebody passed the wrong user ID, in which case the user is not going to be found. What happens when the user is not found? So what could we do? We could return null. That's one way to do it, right? Because we're trying to get a user object. We did not find a user. So, the most logical way to do things without exceptions is to just return null, right? That's one way to do it. I've seen some code return false or even return -1, right? It's not great, but it's possible. So for now, we're going to go with returning null. So we're going to take our statement and we're going to do what we should be doing, which is to catch the exception, the no result exception for the ORM. But we're going to do something really evil. We're going to just return null right now, right? So here you go. In red, we're going to return null. Now, doctrine does the right thing, which is it throws an exception. But despite the fact that doctrine is doing the right thing, we're going to do the wrong thing. We're going to just return null ourselves. While this is not something you should be doing, I have seen this in code, right? And it's kind of a convenient way to handle when things are not found. Obviously, we're going to show you the right way to do it. But for now, we're going to go with this. Okay, so no result was found. We're returning null. So now let's look above the repository. Let's look at the product service. We just go one layer up. So the product service is calling the user repository, get user by ID. But because get user by ID could return null, then the user service above it has to handle this case, right? So I'm going to put a null check. If is null the user, then return maybe an empty array. So returning an empty array is pretty convenient, because I'm supposed to return an array of products, right? So if the user is found, I will get the products from the repository and then return an array of products. And then if I cannot find the user, I'm going to return an empty array. We're going to show you obviously why this is confusing and not good, but at least this seems like the most convenient way to do things without using exceptions. And we put this null check because we don't want to send a null user object to this method here. Okay. So now what happens is if no user is found, I'm going to return an empty array of products because it feels convenient, but it's kind of weird, right? Imagine somebody using the service. This is a little bit of like a unexpected behavior. And so now what happens is we're going to get an empty array of products in two cases. The first case, if we pass the correct user, but that user has no products, that's okay. And then, but the second use case is if it's no user was found. So yes, this first case is okay. That's a legitimate use case. But this right here, no user was found, that's really strange behavior. It's not good. So if I want to not confuse a user of my service, I could try something like this, right? The product service could try to handle things differently instead of returning an empty array. So let's say I get a null user from my repository. Instead of returning an empty array, I could try to signal the fact that I got a wrong user with a special case. I could -1, right? That's weird, but yeah, I could return -1. So I'm using -1 to signal the fact that no user was found, right? So if my get products for user method returns -1 instead of an array of products, that's how I'm telling anything upstream of get products for user that I could not find a user. So now things get strange, right? Because now I'm getting inconsistent return types on this method. That's already kind of a smell, right? In one case, my method could return an integer, a negative integer, and in another case, it could return an array of objects. So already, things look bad. So yes, I return -1 to signal that no user could be found. So now my service can either return an array of products or -1. So that's not great. So now let's look upstream of the service. You have the controller now, right? So we're going to look at the controller. So the controller could be receiving a -1. Okay, but so we're going to look at so now based on what the service returns, the controller has two options. In option 1, the controller could also always return an array of products. It could return an empty array of products even if it does not find a user. And then option 2, the controller could try to be smart, handle the -1 case such that it can signal to the user that a wrong user was passed, right? That's one way to do it. So we're going to look at both options. In the first option 1, I'm not handling the error conditions. So option 1, the product service is always going to return an array. So the controller has no way to detect that no user was found. And so as such, the products controller is always going to send out an empty array in all cases. So now the consumer of products controller, which could be somebody talking to your API, has no way to know that they passed in that they gave us the wrong user ID. We're not telling that they gave us the wrong user ID. And so they go on thinking that the user has no products. So option two, we're going to try to be better, right? We're going to try to handle the fact that the product service returned -1 when no user was found. And so now the products controller also must handle that special case and send a custom message to the end user saying this user does not exist. Okay, so let's look at what option one looks like, right? Option one, we're not handling the error case at all. So the code is going to look pretty simple, right? So this is the products controller. It's just one line, really, because all it does is call the product service, and it's not trying to handle the error condition. That's one way to do it, right? So yeah, if a non-existent user ID was passed, the empty array is still returned. Okay, so that's for option one. And so now your API consumer is going to be confused. Okay. So now let's go with option two. In option two, we're going to try to handle this error condition in the controller code. So we're going to take this code here and we're going to augment it like this. So now first we retrieve the products. The first thing is we get the products, and then we see if the value of products is literally -1 instead of being an array of products, right? We see if the product value is -1, and then we send an error to the end user saying bad user ID, right? So at least we're handling this error condition. That's something. Else we're going to return the array of products if everything went all right. So that's kind of how you typically handle error conditions when you're not handling exceptions, when you're not using exceptions. So the pros of this approach is at least we're not confusing the API consumer when they send a bad user ID. At least that's something. But the cons, it's a lot more code, right? And it's a lot more ugly code. And now we're mixing in the controller, we're mixing user-related code with product-related code. If you think about it, the controller wants to get a list of products. But now inside of the code of the controller, you see a lot of code handling user edge case and products code. So, and the other thing is now your controller has to know what -1 means, right? This special integer. So you're going to start seeing a lot of impacts in your code. But the thing to keep in mind is that this user repository that we just looked at could be used by dozens of services. And each service is going to have to check for null when there is no user. And in turn, is going to have to find a way to signal the fact that it did not find any user upstream of it to the controllers using this special integer called -1, for example. And then the controllers are going to have to handle -1, right? So you can see kind of the cascading impacts of having this error handling with different return values, right? It's going to have to do that every time. So now imagine these challenges with when you have dozens of repositories used by many services, used by many controllers. Your code gets really, really painful. And now you start having rampant status codes all over your code, -1, -2, -3, -4. And then, you may want to also have human-looking status messages bound to those. And so what you might do is you might have like a global lookup arrays that map a status integer to a status message, right? Your code starts looking really nasty. So it's going to be a lot of code. And what happens is then people start to compromise on error handling. And that means that a lot of error conditions are not going to be handled. And when they don't get handled, strange behavior is going to creep throughout the system. So this is where exceptions can help us. As DJ Khaled famously said, the key is that exceptions are king. But we're going to see why. So let's go back to our user repository where I was returning null. Let's not do that anymore. So I'm going to make that go away. And instead, I'm going to throw new user not found exception. So that's a new exception that I created. Now that I'm doing that, this is what an exception class could look like, where I pass in the user ID that was attempted. And so I can tell the user, hey, this user ID does not exist. User ID could not be found. That's one way to do it. You might see that I put an int val in there because I'm expecting an integer even though it's coming in as a string, it's functionally an integer. And I like to kind of wrap that into an int val in case somebody tries to do kind of a security hack where they try to do a cross-site scripting attack. So I'm going to show you the exception flow. As we looked at earlier, we have our products controller. Below it, we have our service. And then below it, we have our user repository. And this user repository is going to throw a user not found exception. And that user not found exception is going to basically bubble up through the entire call stack. If nothing catches this exception is going to be shown by the framework to the end user. And if that happens, that exception is actually, if you look at the name of the class, that exception tells exactly what happened. In addition to this, inside of my exception class, I can start, embedding other information to signal a more helpful message to the end user. Right. So when we do this, now we can simplify our error handling code because we can make it just go away. So this is a user repository that we just looked at where we throw the user not found exception. That's good. So now we're going to simplify the product service above it. So we just looked at the repository. Now we look at the service above it, and we're going to simplify it. So remember this null check that we had earlier? Well, we're going to make it go away. Boom. And now the code looks a lot simpler, and I can just simplify it a little bit more. Boom. So now all I do is I get the user, and then I return get products from the user that was found. And again, I don't need to handle the case of a user being not found because I am throwing the exception inside of my repository. So now let's go one layer up, right? We had the repository, then we looked at the service, and now we're looking at the controller. So remember this code that we did to check that the products was like -1. Ugh, we can make that go away. Boom. And now the code looks a lot simpler. All right. So now we are in a situation where we are handling an error condition and our code still remains simple. So yeah, there are a lot of benefits to exceptions. It's less code to handle error cases. You can localize the signaling at a component level. You can encapsulate more information. And this is what I like the most about exceptions is you can decouple. You can decouple upstream from downstream components. So upstream components don't have to know about downstream error cases. It allows you to separate the signaling of an error versus the handling of an error. These two things can happen very separately. They don't have to be coupled. So I'm going to show you some better practices for exceptions, things which have helped me over the years. I like to catch ORM exceptions and rethrow my own for two reasons. One is an ORM exception is usually not helpful to the user, right? So if something happened when you try to retrieve some data, you want to try to have a helpful message. If a resource was not found, you want to be able to tell the end user which resource was not found and why. And then the other big reason is security. It is always possible for an ORM exception to leak sensitive information about your database connectivity. As far as I know, both Doctrine ORM and Eloquent are good. You know, they don't leak out this information, but you always you never want to trust it, right? So for both usability and security, it's a good idea to always try to catch ORM exceptions and rethrow your own. And as such, making lots of custom exception classes makes a lot of sense. You want to avoid just throwing a new exception with a different exception message. The class itself really helps make your code a lot more readable, and it also helps frameworks convey more helpful information to the user consuming your code. So try to we're going to look later at what an exception hierarchy and taxonomy looks like, but try to avoid reusing the same exception with different error message. Try to make a lot of custom exception classes. It's a good idea to embed a helpful message inside of the exception. That's why there is a message field on an exception class. And try to give them very specific names, right? Don't say, you know, resource not found exception. Try to say a user was not found, right? That is a helpful class name. User was not found, or user not found exception. Product not found exception, for example. And like I mentioned earlier, if your exception echoes information that was passed to your code, try to be mindful of cross-site scripting vulnerabilities, for example. So why I will wrap my user ID into an int value. All right, so now let's look at polymorphic exceptions. We're going to take a look at what Doctrine ORM looks like. So this is my user repository that we looked at earlier. And you will see that in this repository, I call a method called get single result, right? Get single result exists as part of the Doctrine API. So get single result has two possible failure modes. One is that no result was found. And then two is that more than one result was found. The contract of get single result is that you will get exactly one result. In any other, if anything other than one result comes back, then you will get these two failure modes. So this is the source code in Doctrine PHP for get single result. So yeah, it's a lot to look at, but you can see right here that no result exception gets thrown, and then here in this part of the code where non-unique result exception is being thrown. Okay, so get single result can throw either a no result exception or a non-unique result exception. So let's look at the call stack, at the class hierarchy. So you have PHP's exception class, and then you have Doctrine's ORM exception, which extends exception. ORM exception can have many subclasses, but one of these subclasses is unexpected result exception. And if I remember correctly, unexpected result exception can have exactly two child classes. One is non-unique result exception, and the other one is no result exception, right? So if you look at the class hierarchy, no result exception extends unexpected result exception, which extends ORM exception, which extends exception. So the nice thing about a class hierarchy such as this one is it gives us more flexibility to catch exceptions. And I'm going to show you what that means. So I can put a catch block to catch a specific no result exception. And then below it, I can stack another catch statement for an unexpected result exception. So it's basically a fallback. This catch block is going to handle any unexpected result exception that is not no result exception, which means it's most likely to be a non-unique result exception. So basically, this catch block is going to handle a non-unique result exception. And if I want to, I can put another catch block below it, another stack, which will be another fallback, right? So if this first case is not being caught, it means that it's some other ORM exception. So I'm going to handle this here. So that's kind of how you can leverage your type system and your class hierarchy to catch exceptions at different layers. And so in code, it could look like this, right? You could catch specifically a no result exception and throw a new user not found exception. And then as a fallback, you can catch unexpected result exception, and then you could log it. And then as a fallback, you can catch ORM exception and log it. That's one way to do things. So in the code that we saw earlier, here's an example of adding another catch block. So I could catch, if I'm not catching a no result exception, it probably means that a non-unique result exception was thrown. So what I might do is I might log it and then throw my own new custom exception. So that's one way to do it. So another way you can catch multiple exceptions is using the pipe parameter. So this is useful when you're trying to catch multiple exceptions at the same level. There is no ancestor between those exceptions, right? You want to say, hey, I want to catch this exception or this exception or this exception. So you can just put a pipe between those statements. So this is what the code could look like. I want to catch a no result exception or a non-unique result exception. And then in that case, throw my new user not found exception. So that's one way to do it. Okay, so that's the pipe. If you work with PHPUnit or if you do test-driven development like I do, it's really simple to work with exceptions. The first thing you want to do in PHPUnit is declare the fact that what comes next will trigger an exception. And then once that happens, you want to actually trigger the exception throwing behavior. And when you have these two conditions met, then your test is going to pass. So let me show you a code example. So I'm going to have a bogus user ID, which does not exist in my system. And I'm going to say expect exception. So I am signaling that an exception will be thrown. And then I am triggering the exception with the bogus user ID. Okay. So this test, if my getUserById method actually throws a user not found exception when the bad user ID is given to it, then this test is going to pass. If my getUserById method does not throw a user not found exception class, then this test is going to fail. All right, so I'm going to show you this in code right now. I'll be coding live. What could possibly go wrong, right? All right, so this is my ID. So on the right here, I have my user repository class. And you can see that I have a getUserById method to which I don't pass an integer. I'm actually passing a UUID object. And then I'm using this UUID object to query my data store for this user ID. And again, here, I'm going to call get single result. So this code works already. I have my test get user by ID, positive test case. And I'm going to run my entire test suite right now to make sure that my tests pass. Okay. So you can see that my tests right here all pass, right? Okay, so now I'm going to write a failing test. Okay. So I'm going to create a user ID that does not exist in my system, right? I'm just calling the UUID objects UUID4 static method. And I'm going to pass this non-existent ID to my method to retrieve a user by ID. Okay, so I'm going to run this code, and this test is going to fail. It's going to fail because my ORM threw an exception. It says, hey, you gave me an ID that does not exist, right? So here's my doctrine ORM no result exception. No result was found for query, although at least one was expected. Okay, so now what I'm going to do is write some code to make my test fail for another reason. So this expect exception of this is going to be an app bundle exception user was not found class. So this is a new exception that I want to throw. So now if I run my code, if I run my tests, it's going to fail pretty much for a compilation error, right? Because this user was not found class does not exist. All right. Reflection exception, user was not found, does not exist. That makes sense. So now I'm going to make this this class exist. So I'm going to option return, create class, and that's going to put it right in my exception package. That's good. All right. I'm going to add it to my repo. So this is the exception class. Now I'm just going to say extends exception. Oh, no, not this one. Extends exception. There you go. All right, I'm going to move my production code to the right. Here we go. All right. And then now I can simplify the FQDN. There you go. User was not found. Okay. So now I'm going to run my test again, and it's still going to fail, but for a more interesting reason. It's going to fail because my ORM is throwing the doctrine exception, but I'm expecting this exception. So you can see the message here. Failed asserting that exception of type no result exception matches the expected exception of user was not found, right? It's a pretty straightforward messaging. So that's good. So now I'm going, and the reason this failure happens, right? The reason my test does not pass is because get single result is throwing an ORM exception instead of throwing this exception. So now I'm going to modify my code to make the test pass. So I'm going to option return here to surround with try catch. Okay. I'm not going to handle non-unique for now. And I'm just going to say throw new user was not found. There we go. And that's pretty much it. So now I'm catching the exception thrown by my ORM, and I'm throwing my own exception now. So now this test should pass. There you go. All my tests passed now. Woo! All right. So let's go back to the presentation. So if you're interested in learning more about test-driven development, I have about 10 hours of videos on my YouTube channel. So feel free to check them out. That's me live coding like you just saw. So some takeaways, with exceptions, you can fail with poise. You can signal failures with less code. You can handle failures with less code. You can reduce your technical debt. You can build more robust systems. So exceptions are your friend. All right, thank you. That's all I had. Here is me on Twitter. Again, feel free to follow me, say hi. And if you want to get my slides, they are available to you here. Thank you.
Thank you, Chris, for your excellent talk. So we've got a lot of questions, and we will ask you them at our Zoom discussion.
Sure.
But what I wanted also to say, maybe you don't know yet, but Crew Dragon docked to the space station, so hooray!
Yes. Yes. Yeah, I wanted to see it during the presentation. It was like, but I couldn't.
This is why we could record your talk and put it so you could watch the live of Crew Dragon, but you did it live, and you can now see the recording of these guys in the space. So you know what? Interesting. It takes 19.5 hours to fly from Austin to Kiev, and it took 19 hours for Crew Dragon to fly from the Earth to the space station. Such a coincidence.
Yeah. Yeah.
So you may choose whether to fly to Kiev next year or to go to space station. Yeah. What a choice. Okay, Chris, let's meet in 10 minutes in Zoom. We were really excited to have you here. Thank you very much, and thank you for staying with us for the Zoom discussion.